Hey guys, welcome back to lecture series on Z transform. For similar videos, you can check in my description box. I already uploaded plenty of the videos there, and for your more information, go and check in I button. You will get the my entire lecture series. In my today's video, I'm gonna explain to you all Z transform of a sine function. Okay, so already in my previous lecture, I explained to you all what is actually the meaning of a sine function of a Z transform. Okay, so that one result I proved here. Okay, for your understanding, go and watch this video. So in my today's video, I'm gonna solve example based on the Z transform, which involve the sine function here. Okay, yes, so let me write the result that we proved in our last part. Okay, Z transform of sine alpha k when alpha greater than 0. Okay, Z transform of sine alpha k when alpha greater than 0, it can be written as Z sine alpha upon Z square minus 2Z cos alpha plus 1. Okay, and when mod z its modulus of z greater than 1. Okay, yes, that one is our Z transform for sine alpha k that we learned in our previous lecture. Okay, so if you are interested to see this proof, you can check in my playlist. Okay, yes, now compare this Z transform with the sine alpha k. Okay, so you can see what is the value for alpha when sine alpha k compared with the sine 4k. So it seems as alpha as a 4. It seems like that alpha as a 4 over here. Okay, so replace alpha as a 4 in our Z transform. See that how I'm going to write Z transform of sine of 4k. Okay, so 4k I'm going to take under bracket here. Z transform of sine 4k, that we have to find. Okay, and when k greater than 0, okay, k greater than 0, I'm going to write this one as Z sine alpha. Okay, Z sine 4, so I'm going to write Z sine 4 upon Z square minus 2Z cos, what is the alpha? Is a 4, 2Z cos 4 plus 1. Okay, so I just replaced the value. Here as alpha 4. Okay, alpha as a 4, and we have mod z greater than 1. Okay, this one is our required Z transform for sine 4k. Guys, if you're going to solve this example now directly Z transform, it is quite bit challenging for us. Okay, it's not challenging, but it is time taking and a lot more lengthy calculation based. So to avoid the calculation, you need to remember this formula. Okay, so Z sine alpha k when alpha greater than 0 can be written as Z sine alpha upon Z square minus 2Z cos alpha plus 1 and mod Z greater than 1. Okay, yes, this one is our required Z transform here. Okay, I hope you all have understood this Z transform. It's not that difficult, guys, one of the easier. So I solved one example here. Now see that, guys, there are so many other Z transforms. So I'm going to write some important Z transform here in our today's lecture, and we are not going for the proof. Okay, so proof it is similar like our previous lecture. So if you want to see the proof, you can comment me in the comment section. Okay, as it is similar like a previous video, so I'm not taking more time to write the proof. Okay, yes, so I'm going to add only 3 to 4 important Z transform result here that will be helpful for us. So here we have next Z transform of cos alpha k when k greater than 0 can be written as Z under bracket Z minus cos alpha completely divided by Z square minus 2Z cos alpha plus 1. Okay, Z square minus 2Z cos alpha plus 1. It is like a mostly similar like expansion of a sine alpha k. Okay, yes, when we have k greater than 0 and modulus of Z greater than 1. This one is the important Z transform, guys. We are going to apply directly example here on these properties. Okay, let me explain with one of the example here. So see here, guys, I added one example, Z transform of cos 8k when k greater than 0. So if you are going to add directly the Z transform, it is quite challenging to solve this one. Okay, so better than this, apply the form here given. Okay, Z transform of cos alpha k Compare the Z transform of cos 8k. Okay, so cos alpha k compared with the cos 8k. So what is the value for alpha? So I'm going to write alpha as 8 over here. Okay, alpha as 8. Replace alpha as 8 and put the values in our given Z transform. Okay, so I'm going to write a Z transform of cos 8k and k greater than 0. Okay, which is equal to alpha I written 8. Okay, Z under bracket Z minus cos 8. Okay, alpha I written here 8. Okay, need to replace the value alpha as Z into Z minus cos 8 upon Z square minus 2Z cos 8 plus 1. Okay, and a modulus of Z greater than 1. Okay, and this one is our required Z transform of cos 8k. Okay, not the difficult guys, one of the easier. You just need to remember the formula. Sin alpha k and cos alpha k has a denominator same for the Z transform. Okay, yes, but only you need to remember Z sin alpha as a numerator for sin Z transform for sin alpha k, and Z into Z minus cos alpha, it is a numerator for cos alpha k. Okay, in a Z transform. Okay, this one is our property 5th. Let's go for a few more properties that we want the hyperbolic properties. Okay, so we want the sine hyperbolic property, cos hyperbolic property. Okay, so we go for this one now. So see here guys, I consider Z transform for hyperbolic function. Okay, Z transform for sine hyperbolic alpha k when k greater than 0, which can be written as Z sine hyperbolic alpha Z square minus 2Z cos hyperbolic alpha plus 1. Okay, and mod Z in the case of a sine regular sine function, we consider mod Z greater than 1, but in the case of hyperbolic function, we consider maximum value between modulus of e raised to alpha and modulus of e raised to minus alpha. Okay, now see that to remember, how can we remember that sine hyperbolic alpha k as a Z transform? Now see that in our sine hyperbolic alpha k, what we learn, Z sine alpha upon Z square minus 2Z cos alpha plus 1, as it is there in a hyperbolic function. As a hyperbolic it is there, now you have to replace hyperbolic alpha k, hyperbolic alpha k and hyperbolic alpha k. Now see that what we have here, sine hyperbolic alpha k. So I'm going to write Z sine hyperbolic alpha. Okay, okay, so we have to replace the value here. Okay, Z sine hyperbolic alpha Z square minus 2Z cos hyperbolic alpha plus 1. Okay, all it is similar like sine hyperbolic function, but I replace only the hyperbolic function. Okay, so trigonometric and hyperbolic gives us the same values here. Okay, but we need to be careful about the modulus of Z. It is the maximum between these two modulus. Okay, e raised to alpha and e raised to minus alpha. Okay, and we have left here one of the last hyperbolic function, which is a Z transform of cos hyperbolic alpha k and k greater than 0 can be written as Z into under bracket Z minus cos hyperbolic alpha. So we can denote it as the arc also. Okay, yes, cos hyperbolic alpha upon Z square minus 2Z cos hyperbolic alpha plus 1, and that modulus Z we are taking similar as a max of a value between a mod e raised to alpha and mod e raised to minus alpha. Okay, so we are taking value between two of them. Now see that sine Z transform of a sine function and sine hyperbolic function, entire it is same, but modulus Z it is a little different. Okay, so this value it is remains same. Okay, we just need to replace hyperbolic. Similarly for cos hyperbolic, Z transform of cos function and Z transform of cos hyperbolic function, both are the same. It need to replace only the hyperbolic function wherever you will get the trigonometric terms. Okay, yes, these are the four important properties guys. Sin Z transform of sin alpha k, cos alpha k, sin hyperbolic alpha k and cos hyperbolic alpha k. These are the way related properties. You can remember it along. Okay, I told you all that how to remember. Okay, these are the equal property that you can remember it easily. Okay, so I hope you all have understood. This is my today's lecture. It is based on some example and properties from the Z transform. I hope you all have understood everything. If you have anything difficulty, confusing, let me know in guys my comment section. I will come up with the similar videos. Okay, so that's it for our today's video. So if you found it helpful guys, let me know in comment section. If you have any doubt, difficulty, comment me in, guys. Okay, or if you want any difficult problem that you can be able to solve, just let me know in my comment section. Upload me photos. I will solve this example in my channel, so you will get the simplified version of that questions. Okay, yes. So thank you everyone. Thank you for my today's lecture.